Hello everybody, I'm Evyatar. I'm a software engineer at Meta for the past almost 5 years. And today we're going to talk about JavaScript Proxies. And sorry about that over-the-top animation, but yeah, I'm a sucker for that. And well, a little bit about me. I'm married to my beautiful wife with which I travel the world. And I am also the humble servant of this mighty creature. Take it for a second, give it a moment. Yes. All right. And in my free time, I build a bunch of open source libraries for any kind of use, mostly fronted, but not necessarily only. And one of which is we're going to talk about today. We're going to build a part of it today, and today we're going to build a fluent assertion library. And that's a lot to take in. What is a fluent assertion library? Or first of all, what is a fluent API? And when we talk about a fluent API, well, Fluent API is sort of an infinitely chainable API that we can chain methods over and over again, one after the other. And it was initially popularized in the world of JavaScript by a seemingly, well, anonymous library. Does anybody recognize this logo? Woo! jQuery, yes, the return of the $sign, I guess. And it used to look kind of like this. Well, you could add like your selector, and after that you could add a class, and you could remove class, and chain as many methods as you could until you ran out of ideas for chaining methods. And this is the notion of an infinite chainable API, or a fluent API, as we call it. And we're going to build a fluent API of a different sort. We're going to build an assertion library, or a fluent assertion library. And what is an assertion library, you're asking? Well, an assertion library allows us to verify the truthiness of an expression by throwing an error in case of a validation failure, in case it evaluates to false. And this means that, well, you've used many of them in unit testing libraries like Mocha or Jest, using assert, chai, or Jasmine in this syntax. And it looks kind of like this. You've probably seen one of these in the past. And the question is, why build our own even? Why do we need to build our own? And in my idea, in my world, it's very obvious. I build an open source library. It's called Vest. It's a form validation framework that's inspired by unit testing libraries. It gives the same syntax and style as unit testing libraries. And if you were here yesterday in the React Next conference, then you'll probably have a deja vu from the next slides, because it's going to be a very similar, just for a brief moment. In a unit test, we have describe, and we can add some stuff. Like, for example, we can add the description for the function that we're checking, or for the feature that we're checking, and then we can test the implementation. So we say, for example, we want to combine two numbers, and then we can expect or assert whatever it is that we want to be truthy. So, for example, in a calculator add example, we want to combine two numbers, and we can add as many tests as we want. And when working on Vest, I thought, well, this could be used for other use cases as well. We could use it for, well, form validation, because if we describe the user registration form and we add the names of the values of the fields that we want to check, or whatever it is that we want to assert, we add the form validation assertions, we add the data that we want from the form, and then we just do some renaming. So, for example, we say we want the username field, and we, well, change it to enforce. And Vest create, we have Vest. And today we're going to work on enforce specifically, this part. We're going to work on the infinitely chainable function that's enforce. We have enforce, data username is not blank. Oh, I lost the screen, by the way. I don't see anything. Yeah, thank you. Cool. And just to know what we're going to build together, let's think and let's see the enforce features that we're going to work on, and what are the features that we have in enforce. So first of all, we have infinite chainable API. That's obvious. We just talked about it. The second one is going to be modifier support. And when we talk about modifier support, so for example, we can add a not modifier. So we can flip the next rule that we're checking. OK, that's awesome. And the last one, we're going to build together a schema validation library from scratch right here, right now. And it's going to take us like 15 minutes, I think. So this is what we're going to do all together today. These are the features that we're going to build. And I don't know if you noticed it when you saw the schema validation. We have two notations of enforce. So we have the main enforce that we call immediately, but within every field that we're checking, you see that, well, we're invoking it without any value. So we have two notations, one that's immediately invoked and one that's waiting with the data, just for a bit. We're going to focus now on the first one. Later on, let's see the other one. And the main question we have is, well, we have enforce and greater than, and the main question is, how do we get the age to the greater than function? Because the way I know functions work is that I have a greater than function. It takes two values, and, well, how do I combine these two? That's the main question that we're going to ask. And the traditional solution, like we've done this before, right? We've used usually classes to do that. And when using classes, usually we have a constructor. In the constructor, we add the value. And then we have the different kinds of methods, like greater than and less than, and add a compare value. And then inside, well, we check if the value does not equal what we expect it to be. And then we throw an error. Otherwise, we return this, and then we can infinitely chain this. But there are a few problems with this approach. And the first one is it means that every function in this class has to have this throw-in logic. And I want these functions to be just very simple. I don't want them to be able to return this. I just want them to be a Boolean return. And I don't want them to be want them to be aware of every feature of that enforce function or enforce infinitely chainable API, especially if I want to allow for extensions. So if I want to add my own extensions, well, that's not going to work. And on top of that, we saw that we have two notations, one that's immediately invoked and the other one that's not. Well, this is not supported. And the last reason I don't want to work with classes here is because I'm here to talk about proxies, right? And if I want to talk about proxies, I don't want to talk about classes. And we're going to have two building blocks when building this. We're going to talk about carrying, which is a concept and technique from the world of functional programming. And we're also going to talk about proxies, which is a very cool feature in JavaScript. And to talk about proxies, just from MDN, a proxy enables you to create a proxy for another object, which can intercept and redefine fundamental operations for that object, which means basically that we can redefine or intercept random attribute calls to any objects and redefine the implementation and do whatever it is that we want. And just to show you, we have proxy traps, which means we can intercept a few main operations like get, set, apply, and has. These are the main traps that we usually use. We're going to talk about get today, but other ones are pretty cool as well. And proxies are like not in the everyday lexicon of most developers, but they're mostly used within libraries. So learning about proxies, you'll also demystify the tools that you use. So for example, I use it in Vest. It exists in PartyTown, which is a very cool library that by Builder.io, the guys behind Quick, that traps third-party scripts within a web worker. We have Vue that uses it for their activity API, same as Mobex. And we have Immer that we use for immutability. So all these use proxies under the hood, and that's pretty cool. And to show you how proxies work, so for example, we want to proxy this person object. And it has the name and the age and the password. And let's say we have the person proxy. And we do a proxy for the person, and then we create a get trap. A get trap. No? Oh, yes. And well, we trap the get, and we get the target, which is the original object, and the key, which is the attribute that we're trying to access. And then, well, let's just return the original value that the user tried to access. And in our case, if we try to access the name of the user, we're going to get John. OK, awesome. Now, let's say that if the object does not have the property that we're trying to access, let's return a fallback. So for example, not available. So if we're trying to access the user's country, we're going to get not available. Now, security matters, and we want to do very hard, strict security, and this is not the way to do security, but just if we wanted to do some security, let's say if key equals password, if we're trying to access the password, let's throw an access denied, because that's how real security is done. And yes, and if we even try to access the password without logging in, without anything, we'll get immediately access denied thrown at us. So this is the basic operation of a proxy, and this is something that we're going to use today. And the second technique that we're going to use is carrying. And carrying allows us to transform a function into a sequence of functions that each takes one argument. So this allows for partial application of the original function. So let's assume we have the add function that takes a and b. And we want to split it to multiple operations. Sorry. So let's do add value that takes and call a carry with it. And I won't explain how carrying works. It requires counting the arguments and returning a function within a function. But the idea is that, well, we have the first one now. We can have the first one add value 1. And then if we log it, we get just a function, another function. And if we run the second function with another number, well, it will perform the add operation for us. So we can break any function into multiple operations in order to later execute stuff as we have the data. So this is pretty cool. And this is something that we're going to use. Now, together, we're going to build some code right now. So wish me luck. Wish us all luck. That's pretty early in the morning for me. But yeah, let's do this. Where did I put this? OK. So let's open the code editor. That's run.js, and I have a few rules already, enforce rules, just for you. And can everybody see all right in the back? OK, awesome. And let's try typing a function. Let's call it enforce. And enforce, as we said, takes a value, just any value. And what do we return? We return a new proxy. And the cool thing about proxies, well, I'm not going to trap or intercept the rules object because, well, I don't want to access it. I just want the dynamic operations of a proxy. So I'm just going to trap an empty object. And then I'm going to create a get. And in the get, I'm going to take the target, which I don't care for. And also, I'm going to get the key, which is the attribute that we're trying to access. And also a self-reference to the proxy object that we're creating. That's very useful for them. So let's just say it's the self-reference for you. And what we're going to do now is check if we have the current rules. So if rules has the key object, has the key property, or has that key, has that specific key, let's return something. And what do we want to return? Let's return a new function. And what this function is going to be, it's going to be a spread of the arguments, and then we're going to check the results. So const result equals, and then this is going to be a little bit tricky, but we're going to access the rules, yes, with the key. So we're accessing one of these rules, passing it the value and the arguments. So this is kind of a carry, what we're doing here. And now when we have the results, if not result, so if it's falsy, then what we can do is throw new error. And what we want to do here is, let's say, failed the rule, let's say, key with value. OK, so we have this. Otherwise, we want to have it infinitely chainable, right? So what we want to do is return that same proxy object forever. So right here, return proxy. And also, you know what, I don't care about the rest. And just like that, let me try. Hopefully this already works at some level. And we're going to do something. Enforce 1. Let's say equals. Do I have equals? No, I don't have equals. Let's do is string. And right now we're saying failed with the rule is string with 1. But obviously, 1 is not a string. But let's try is number. And we're getting a proxy back. Now, if you don't understand, this is a good result, because this means that we can infinitely chain. So let's log this just for the logs. And we don't really need it in production, but just for us, let's say console.log passed the rule key. And we can see that we passed the rule is number. Now, let's continue with another item in the chain, and let's do is number, and let's also do greater than. So let's try 10, and let's say greater than do we have a greater than? Yes, we have a greater than. Greater than, let's say 5. Yeah, cool. So we pass the rule is number, we pass the rule greater than, and we have the proxy back, so we can continue forever. So, for example, is odd, and, is even, and then forever and ever and ever and ever and ever and ever. Yes, we have all of that. So we can infinitely chain already, and that was like, I don't know, 10 lines minus the braces and console logs, so that's pretty dope already. Cool. Now, let's try now with modifier support. So I told you we're going to be able to do some not and flip the switch. And this is, well, that's difficult, right? How do we do that? We don't have a not function. How do we flip the switch right there? And apparently that's easy as well. And what we're going to use is a very basic JavaScript concept called closures, and we're going to make use of that. So what we're going to do here is create a new variable. Let negate next. Negate next equals false, which means that if we get negate next true, we want to flip the result and return false when it's true and return true when it's false. So what we're going to do now is, well, if key equals false, and again, this is the cool part, because even though we don't have any property with this name, we can do whatever, because JavaScript Proxy is super dynamic and allows us to do whatever it is that we want. So I'm going to do if key equals not, negate next equals true, and we want to return the proxy. So return proxy. Now, this does not do anything just yet. It just returns a proxy. But what do we have here? We have the result. And what we can say that here is that if negate next is true, we want to return result. Otherwise, we want to go by the opposite of result. And just so it flips the switch back again, let's reset it if the rule is true. False. OK. And just like that, if I start typing, so let's go here, and force 10 is number, but let's try the opposite of that. And force 10 not is number, and we're failing because, well, it's not is number. And let's try again, not is string, and it's passing because, well, not works as expected. Cool, so it's like, I don't know, now it's 14 lines. Now it's around 14 lines and it's already working, and let's try to chain more stuff. And now we said that not only applies for the next rule in the chain, so it should auto reset. So let's try now not is string and is number, and we're going to be able to pass both. That's pretty cool. Cool, so in just a few lines we created a fully functional validation library, assertion library, infinitely chainable assertion library with proxies. That's awesome. And let's go back to the presentation. Right? OK. And the main question and the main interesting part that I wanted to do is, what about schema validation library? Because that seems a little bit complex. That seems like over the top complex even. And has anybody used schema validation libraries like Zod, Yap, Joy, Happy? Yes, yes. These are amazing libraries. I love them, especially Zod, which is really, really, really good recently. Though Valleybot is giving it a good fight. And we're going to implement enforces schema validation, which is going to take the enforced syntax. So we're going to have the object in the beginning, and we're going to have the schema at the end. And of course, it can be composed, it can be saved, but just for simplicity, we're going to do this. And the complex part is, well, we have this notation that we call enforce immediately with the value, but the value is down here. And what we want to validate it against is the value, the schema or the rule that's down there. How do you do that? How do you connect these two? Right? And, well, we have value is string, and right now we're going to use it like this. And I thought it would be very easy to use carrying in the same sense that we talked about earlier, like this. We could pass the value at the end and make it run like this. But you're not seeing me do this inside of the schema, of course. It has to be done internally. And how do you do it? Well, we have a very quirky thing about JavaScript, and in JavaScript, almost everything is an object, which is pretty cool, pretty awesome. Functions are objects too. You see, we can do a new function, we can put properties on a function, we can log these properties, access them, and this means that we can also apply proxies on top of functions. This is the key part. Now, for example, if we were to rename our existing function that we just created to enforce eager, which eagerly invokes the implementation of enforce, we can wrap that one in a new proxy object we call enforce. And we're going to do that. You don't have to memorize this code. And this is going to be like proxy inception. It's like a proxy within a proxy. This is pretty cool. And it sounds complex, but I think it's pretty simple once you see it. So let's go back to the code. And let's rename our function enforce eager. Now, let's do const enforce equals new proxy. And this time, we're going to wrap the enforce eager with that proxy. So we have a function that's wrapped to a proxy that returns a proxy. Oh my God. And now let's do something like this. So get, and then I don't need the initial argument. Let's get the key, and we have the proxy reference. Okay. Now what we want to do here is if rules has a current key, again, what we want to do is return a function. Now here, as we saw before, we're flipping the switch. We're first passing the arguments, then passing the value. So we're doing this right now. So args, and then return value, a function that returns the value, that takes the value, and then if rules key. You know what? Let's do something like this. Let's just return it. Return rules key value args, and that's like, I think, it for the basic part, for just returning the value. So what we're going to do now, what we're going to try, and our previous example still works, but let's try something different right now. So let's do enforce is string, and we're getting a function back, which is what we're expecting. And what we're trying to do now is, for example, my name. And it's a string, but let's try something different. So for example, a number, and we're getting false. Okay, so we have the basic operation of that part working. Now, how do we make it work in a schema? That's, well, easy, I think. Let's try it. So let's create a new rule. Let's call it shape. That's the schema function for vest. And it will take two things. It will take the object, and it will take the shape. It's kind of weird that I called it in the same name, but let's call it shape just for brevity. And what we're going to do here is for const key in shape. So for each of the keys in shape, let's check first if not key in object. Okay, throw new error. This key is missing. Okay, perfect. Now, otherwise, let's check if not rules rule, and this is going to be a bit trippy. If rule key, then we check for, if rules, yes, okay, shape, what? Oh, sorry. If not shape key object key, I think that's how it works, then we're going to return false. Otherwise, let's not do anything and then return true. Hopefully this works. And if everything I just did works correctly, let's try to run a schema with this. So enforce, and let's do shape. I really, really hope this works. Enforce, so for example, let's do a shape, so name, and then first Evyatar, last Alush. And what I'm going to do now is shape. And right here, I'm going to do, for example, name. And then in the name, I'm going to do, well, it must equals another shape because it's a nested shape. It's a shape within a shape. So enforce.shape, and then first enforce.isString, and last enforce isString. And this key is missing. So which key is missing? Why is that? If not key in object. Let's see. This is a bit of a problem. What? Spread the arguments? Oh, I think you're right. Yes. Awesome. Thank you for that. Okay, so let's try now with adding a field that does not exist. Like let's add a middle name. Middle enforce.isString. And right here, we're saying this key is missing. We don't have it in a source object, so we're not seeing it. So let's add also the opposite check. So if we have something in the source object that does not exist in the schema, let's throw as well. So for const key in object, and then let's say if not key in shape, and let's say found an access key. Okay, and now let's try the opposite of that. So let's do middle, and let's do, I don't have a middle name, so that's not gonna work, but found an access key. Cool, so we have like the basic implementation of a schema validation library, and it can go as down as we want, as little as we want. And of course, we can add many more features and many more capabilities to this, but the source thing works like magic. And when we take a look at enforce, so let's do Vest.js, Vest Validations Framework. By the way, you should totally go and see the documentation page and try Vest if you haven't already. And let's go to enforce. We have our many more enforce rules that we did not see today, and we have internal plugins, one of which is a very lean but very cool validation schema validation library that works very much like we described today, but with partial and arrays and more capabilities, and it's pretty cool. Now, my main takeaways for today, I think, is first of all, let's go skip that because we're not in, we're a bit in a hurry. I think that these learnings for me are mainly based on the things that I build, on the things that I try, on my plays, on my games, and that's because I try to build stuff. I try to build stuff on my own. I try to see how the things I use actually work, and this is very magical to me. And I think what helps it the most is that I try to explore. Well, people tell me don't do this, and then I do this. I try the stuff that people don't try, and well, you should too, because it gives you a lot of confidence in the tools that you use, understanding how they work. And lastly, we mostly use the fundamentals. I mean, we did try proxy, but we used closures and carrying, and we used hoisting, and everything that's just in the fundamentals and the basic of JavaScript. And having a solid understanding and solid base of the foundations of JavaScript will take you such a long way when working on everything. And we're just out of time right now, so thank you so much. Have a great day.